So last lecture was this one. It was getting quite big, so I decided to split it into two different lectures. So let us now see some interesting points. How do we get the intuition that the above described problem, which was the Boolean parenthesization problem, it can be solved by dynamic programming approach? So this was the question. So answer is this: it satisfies both the properties which are required for a problem to be solved by dynamic programming approach. So your next question will be this: which two properties are those? कौन सी दो properties हैं वो? Answer will be this: we have already seen some dynamic programming problems, such as few lectures back we talked about this problem of maximum subarray, but till now we have not discussed which problems exactly fall in the category of the dynamic programming. And this concept of dynamic programming is kind of vague till now, so let's make that concept concrete here. So these are the following two properties. First one is overlapping subproblems, and the second one is optimal substructure. These two properties make a problem to be identified as solvable by dynamic programming approach. So let us now see what each of these mean and how the current problem is satisfying these two properties. Current problem implies the Boolean parenthesization problem. So let us first look at this overlapping subproblems property. Let's understand what is meant by overlapping subproblems. First, we take a simple example of Fibonacci series. Fibonacci series is f0, f1 are 1, and 2 onwards the value is of fi. This is fi. It may not be visible from there. Fi is fi minus 1 plus fi minus 2. That is the sum of the previous two numbers. So this is a quite simple formula. This is called the Fibonacci series. So the numbers are 1, 1, then it will be 2, then 1 plus 2 is 3, 2 plus 3 is 5, right? And then 2 plus 3 is 5, and then 3 plus 5, 3 plus 5 is 8. So this goes on like that. So let us say we want to find out the value of f5. That is the fifth Fibonacci number, and if we start from 0, then it's the fifth Fibonacci number. That is the sixth Fibonacci number if we start from like that. So we will try to depict this problem in tree form, where to solve a parent we need to solve its children. So this is the tree form of the problem. Let us see how this tree form looks like. So this tree form looks something like this. So this is the tree form. In this tree form of the problem, to solve f5 we need to solve f4 and f3. First we solve f4, then we solve f3, and whatever these two children return, I will sum them to get f5. How f4 is calculated? f3 and f2 are being returned from my children, and I am summing them to get f4, and I am giving it to my parent. Similarly, f2 and f1, they are returning me something, I am summing it and returning to my parent. So this is the recursion tree for this problem. I hope this is clear. So the leaves denote the base cases. There are 3 points to note here. First of all, the leaves denote the base cases because f1 and f0 are defined to be 1. So if we get to f1 or f0, these are all the leaves. So then the recursion ends. This is the base case, base condition, whatever you call. Let us now examine what is meant by optimal substructure. f2 is returning me something, f1 is returning me something. So they are returning me optimal results, their optimal results, and I am using their optimal results to compute my optimal result, that is f3. I am using this and this to calculate f3 because I am just summing them. So this is called optimal substructure. The subproblems optimal solutions can be used by the parent to construct its own optimal solution. So here the simple solution is there is no optimality, but in some special situations, the more complex problems we will see, there the solution needs to be optimal, that is the best solution. Lastly, we observe this interesting point. f2 is occurring at three different locations in this tree, this one, and this one. So the same subproblem of f2 is solved 3 times effectively. So the problems are overlapping, subproblems are overlapping. f4 also needs f2, f3 here also needs f2, this one also needs f2. So at various points in our recursion tree we are needing f2. So these are the subproblems which are overlapping. Somehow they are overlapping, this and this are overlapping. So this subproblem is overlapping with this subproblem. So this is called the overlapping subproblems property. I hope this is clear. So let's read through some text. Please observe how many times f2 is needed, which is shown circled. So here it is shown circle. So 3 times, and each time it is needed, we recalculate its children and then we again add them to obtain the value of f2. So each time it is needed, here f2 is needed, it is calling its children f1 and f0, whatever they are returning it is summing. Here also it is doing the same thing. So here we are doing the same thing as this one, and here also we are doing again the same thing. So why can't we do it only once and just store the result and use it for the future? So we just calculate it here, we don't need to recalculate here and here, we just use the previous value. So this is the point of dynamic programming. So 3 times, and each time it's needed we need to recalculate its children and then we again add them to obtain the value of f2. Similarly, we can observe that f3 is also recalculated twice. Let us see. Here f3 is there and here also f3 is there. So it is also calculated 2 times. So this is bad. So wouldn't it be better, that is time efficient in terms of computing? So what would be better if we just compute f2 and f3 once and store it somewhere for future use, so that we are saved from the overhead of doing the whole process again and again. This sounds quite interesting, but this sounds quite vague also. This is quite abstract. You will say you are just telling some things and not providing any concrete code or some algorithms. So I wanted to cover those algorithms or codes in this particular lecture, but looks like this lecture has already exceeded the time, so we will continue this in the third part of the series, next lecture. Thank you, friends.